What up, Fat Finger Squad? We got Danny in the building, plant-based brother. What up? We got my man Keep It Techie, Josh from Keep It Techie in the building. If y'all want to learn a little bit more about Linux, y'all check out his channel. Today we are covering OSPF, configuring the router ID manually. We'll give it some time for some late stragglers to come in and stuff like that. Josh, you know what? I forgot. I didn't know it was this Saturday, man. I remember we said we was gonna plan it, and I have my spring break coming up, but I got my daughter this Saturday. I still got your contact information. Hit me up. Actually, no, I'm gonna hit you up tonight, and then we'll discuss a little bit more about it. I forgot it was this Saturday. I remember we planned it, but I didn't know when it was. So I'm gonna hit you up. For y'all that don't know, me and my man Josh from Keep It Techie, we was planning a collaboration interview. And he was having me as a guest on his channel. I guess I made it, y'all. Mama, I made it. That is Josh's channel if y'all want to check him out. But just messing with you. Oh, okay. I was like, damn, that was it Saturday? I like that, man. My man got a sense of humor here, man. For this lab, we only need 2 routers back to back. And we're going to connect them. Serial interfaces. I'm gonna change the name. I think this will happen because I was He's gonna be R1. Let me check the book because I'm pretty sure it's gonna be this router 1 and router 2. Remember, we only just need 2 routers. This should be a quick and easy one. We should knock this one out in less than a half hour. But y'all know I talk shit for about a good 10-15 minutes. Wait for the late stragglers to come in, and then he don't want to change, do we? Is that because this is already a lab with routers in it? I don't think that's why. But yeah, I got your contact information though, and then I would definitely let you know. You know what? I'm gonna let these bad boys let them stay as router 3 and router 4 because I don't know why. I was dragging and dropping some routers in here earlier just to see if GNS3 was gonna play nicely with me today. And it did, so then I deleted them, and they stand as router 3 and router 4. Let's see what happens if you pull these bad boys down. Let's mess with because see, these don't got serial interfaces. That's why I don't want to mess with these guys right here. So let's do this. Do we have any other routers in here? What do we click delete after that? Delete those 2, right? Yep. See, I'm doing select all, and there's only 2 in there. No. And I want to change him to router 1, but he don't want to change his router 1. Oh, man. Come on, man. Play nicely with me today, man. Come on, GNS3. Let's start a new one. And then try another one. Y'all know me. I like it must be a 3 out of 10. Wow, I just finished this lab in 6 minutes. See, yeah, I told you this should be a real easy one, man. But y'all know, man. I give a little, small little tutorial at the beginning. Wait for some late stragglers to come in, talk shit, and then we get the lab going. So we should be able to knock these out in less than 10 minutes, like the book say. But y'all know, man, I got some commentary. I got my Orlando Magic shirt on today, and I don't know if anybody in here is an Orlando Magic fan, but man, we just gave away today was the trade deadline in NBA. I don't know if you guys watch basketball or not, but we just gave away our best players, man. And whew, it's just not a good day in Orlando, man. I don't know what they have planned, and I don't know what they got planned in store, or what was the idea behind it. We still got Aaron Gordon, do we? Or did we get rid of him too? I don't even know, man. But if you got this lab book, it is page number 49. I'm sorry, 49. Lab number 49, page number 212. If you guys want to follow along, this is the book that we get our labs from, 101 Labs, Cisco CCNA version 4. You can get copies from 101labs.net. It's authored by Paul Browning, co-authored by Farai Tafa. Experts agree that we retain only 10% of what we read, but 90% of what we do. And believe it or not, they also got a Linux version of this book. And Josh, are you aware of that? They got a Linux version of this book, and maybe we might, sprinkle a little Linux in there and bring you on as a guest to help us out, because I don't know nothing about Linux. So, other than him being a character in the Snoop cartoon, isn't that his name? No, I'm just kidding. I think his name was Linus or something like that. But let's go ahead. You know what? I'm gonna do this. I'm gonna relaunch GNS3 and see. Nah, you know what? Let me just name a router 3, router 4. Let me just stop playing with y'all. Serial 20 to serial 20. power these bad boys on. And Plant-Based Brother finished this lab in about 6 minutes, so I don't know if we'll ever beat that record, because y'all know I talk too much. Too much. Scroll up here. Let's get the labeling and the cabling. That's the other thing too. You know, this is in case of some new people and don't know too much about Ospf and stuff like that. I, draw a little bit on there just to let you guys know what is what. You know, he probably don't do any labeling and cabling. He just get it out the way because he got the book, right? So the network is the 172, or not the network address, but this is the IP address for that interface, 172.16.1.1/26. And the other guy is going to be 1.2/26. Y'all with me so far? Right? That's the IP address. That's going to be the IP address once we configure it. And these guys are serial interfaces, right? As you can see right there. Right? Boom, 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 boom. We'll rename him to be, come on, man. Come on, Vlad. Come on, Vlad. 1.2. That's just let me know. Okay, yeah, for sure, man. Yeah, they have a Linux version of this book, man. They have a Linux version of this book. They got a Wireshark version of this book. They got a what else they got? They got the CCNP version. They got the CCNA version, obviously. It's like 8 books in this series, man. But yeah, they like I said, I really don't know too much about Linux, man. And they do have a Linux version of this, and maybe we need to step our Linux game up, because like I said, I had a job interview, man, and they asked me some Linux questions, bombed it. And it was a great network engineer. I mean, I ended up getting a network engineer role after all, but still, man, that would have been a nice gig. Console into that boy, console and the other bad boy. Y'all with me so far? Remember we said OSPF works in areas, so let's go ahead and display that, right? These two are going to be in the area 0, which is also known as the, everybody except Kelvin, Danny, and Plant-Based Brother can answer this question. What is area 0 known as? You get a, if you answer that question correctly. That's y'all pop quiz for today. So that means, I guess, Josh can answer this question. He like, man, I don't know nothing about no damn OSPF. What is that, man? Ospf? Change the style. Let's pick today. Let's go with light blue today. What is OSPF area 0 known as? When we're designing OSPF networks, we start off with area 0. I'm just kidding. Any of y'all can answer that question, man. Y'all know I always be talking shit, man. Let's go ahead and lower him. And we said that he is going to be in area 0, right? Which is also known as, whenever y'all answer that. We are consoling the 2 bad boys, and let's get to starting here. The lab objective is for us to learn and understand how to manually configure the OSPF router ID. So if you know anything about the router ID, right? Remember we said routers that are in a specific area, right? They're participating in OSPF. Everybody has a router ID, right? It's not necessarily this interface right here. It could be the interface. Who knows? And it just depends on the election process, right? And I'll explain what the election process is for the router ID, right? But in this case, it could be the physical interface, right? But what was I going to say about that? So when we're participating in OSPF, we each have our own router ID, right? And let me bring that up. Let me just bring that up. Plant-Based Brother just bought the buck too. Oh, that's what's up, man. Ospf. Yeah, he lost to Cisco. It's all good, man. So anyways, area 0 is also known as the backbone area. Remember we said that? We start off when we're designing an OSPF network. We start off with area 0, and it's known as the backbone area, like that. So that's what I wanted to do there. And that's why you knocked this out real quick, Plant-Based Brother, because you ain't drawing and doing all of these little funky graphics like I'm doing over here. But yeah, no, I'm just doing some lecturing and stuff, right? By default, if only physical interfaces are configured on a router, the highest IP address of those interfaces is used the router ID. So It's kind of like, I guess, yeah, just ID. It's almost like a name. Remember we say hello to our OSPF neighbors, right? It's like, oh, you say hello. The other person says hello back to us, and it's like, oh, you speak OSPF? The other router's gonna be like, oh, yeah, I speak OSPF. Oh, I speak OSPF too. Let's exchange routes, man, because I need to know how to get around this OSPF network, right? And then they start exchanging routes, and then finally they become neighbors, right? But while they're doing all of this too, it's like, yeah, my router ID is blah, 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 blah. Oh, my router ID is blah, 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 blah. And then they start becoming neighbors. But remember, we said that there was a process, right? They start off in the down state, the init state, and then the exchange and the X start, et cetera, until they become full, right? So now, the way that the router ID is determined is, and it's going to be in the rest of this book, but first it picks the highest loopback address. It picks the highest loopback address, right? So, as I drew right here, we don't have any loopbacks. We have just this physical interface. Well, that's because we haven't configured anything yet, right? We've got this physical interface right here, right? Serial 20, and that's going to be his IP address, right? If we had a loopback address, that would be his router ID. Right, that's the first thing we're gonna pick. The router ID, the loopback address, the highest one. Let's say we have 5 loopbacks on this router 3, right? The one with the highest IP address, that's what we're gonna pick as our router ID. If we don't have any loopbacks, then we'll go to the highest physical interface that's up. Its IP address, the physical interface, its IP address, right? So in this case, we only have. Let's console in the router 3 real quick. Console in the router 3. We'll see. So we do a show IP interface brief. We haven't done any configuring yet, but we will, and I'll show y'all real quick, right? So, geez, I'm excluding unassigned. How you gonna exclude unassigned when you haven't assigned anything yet, NetworkBruh? So right here, we've got how many interfaces we got? We got 1, 2, 3, 4, 5, 6, 7. We've got seven interfaces here, right? And none of them have an IP address, so none of them would be our router ID. We probably won't even have a router ID. But our physical one is going to be 200 or serial 20, and then his IP address is going to be that. So guess what? That's going to be the router ID, right? Same thing with this side. This is very similar to the topology we had yesterday, right? So let's go ahead and what else did it say here? So, however, okay, so yeah, that's what it was saying. By default, if only physical interfaces are configured on a router, the highest IP address of those interfaces is used as the router ID. And that's what's going to happen here, right? However, if both loopback and physical interfaces are configured, then the loopback interfaces are preferred when Cisco IOS selects the router ID for the OSPF. So remember, it's going to pick the first loopback. If there's loopbacks, if there's no loopbacks, it's going to pick the physical interfaces, the one with the highest IP address, right? However, the recommended method is to select a router ID. The recommended method to select the router ID is to manually configure it. And that's what they're going to have us do. So that's done automatically, right? Cisco IOS is going to say, do we have any loopbacks? It has an IP address? Okay, let's go with that with the router ID. And then if there's no loopbacks, right? Oh, there's no loopbacks. Okay, well, let's go with the physical interface. The highest one, the highest IP address. Is it up? Okay, it's up. What's the IP address of that? Is that the highest IP address? Okay, let's go with that with our router ID. And then when we start looking for OSPF neighbors, hey, what's up? You speak OSPF? Yeah, I speak OSPF too, man. Well, my router ID is blah, 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 blah. But you want to manually configure it. That's what they recommend you do, right? So let's go ahead and get started, right? So task 1 was to configure the host names of router 1 and router 2. I mean, router 3 and router 4 in my case, because I couldn't figure out how to delete the damn router and change it, right? So he's already router 4. The other guy is probably already router 3. Yep, see? So, and I'm going to go with that because I don't want to start over again, right? So task 2, we only got 4 tasks here. Configure router 1's serial 00, which is a DCE, to provide a clock rate of 768 kilobytes per second to router 3. Remember, we said when we have serial interfaces, one side got to do the clocking, which is going to be router 3 in this case, and the other side is going to be receiving the clocking, right? This is going to be the DTE side who's doing the clocking. DTE is data clocking equipment? Sorry, DCE side is the data clocking equipment. He's doing the clocking, which is going to be this guy. And then the DTE side is the data terminating equipment. He's receiving the clocking. Let me give y'all the official definition though. DCE versus DTE. Yep, that was right. So Google that for real quick for y'all, right? What's the difference between the two? So DTE stands for data terminal equipment. DCE is data communications, my bad. Data communications equipment, not clocking. Sorry about that. So DTE is typically either a dumb terminal, I guess router 3, router 4 is gonna be dumb, or the serial port on a computer workstation. DCE is typically a modem, DSU or CSU or other piece of data communications equipment. Hence the names. What's the difference between the two? Terminal equipment is used to describe the initiator or controller of the serial connection. And the term DCE equipment describes the device that's connected to the DCE, such as a modem. So let's go to route 3 and do the clocking, right? So we'll go to global config mode and we're going to say interface serial 2/0. His IP address we said was going to be what? Y'all with me so far? Anybody lost or anything? Anybody had questions? His IP address is 172.16.1.1. Subnet mask of /26, which is 255.255.255. All right, yeah. Dot, not 128, but 192. Right, we got to convert that. And then by default, the router interfaces are down, so we no shut those bad boys. Right, we check our work with show IP interface, show IP interface serial 2/0. Remember, we check our, once we configure something, we check our work. And then once we check our work, we verify it again. And then we run a show command to verify it again. 172.16, 1.1, so that's correct, right? So we go to router 4, do the same thing on that side. No, we got to do the clocking, my bad, see? Let's go back, do the clocking. Right, and we can verify that with show controllers, right? Typically, it'll say, sorry, let's do this. Show controllers serial 2/0. Something else I wanted to show y'all, and I'll show y'all again about the router ID process, the selection process, in a little bit. I found some a free. There's tons of free CCNA guides that are out there. Don't act like you have to rely on the official cert guide because Cisco gave it to you in this official Cisco Press material. There's so much free material that's out there. For example, this website right here, free. What is it? StudyCCNA.com. It's free. So you want to learn about Ospf, EIGRP, RIP. Y'all know my favorite routing protocol. Even though it need to rest in peace. IP addressing, all of this stuff, right? So this is a free. It's like a free. It's damn near a free book. So if you want to go ahead and check that out, I'll go ahead and leave that in the comments below there. So, and matter of fact, don't even use just one resource. You know, if you do have the official cert guide, great. But then use something else that'll explain something that might explain something different the way I do, right? So this is what we was talking about here, the Ospf Id, right? Using the router ID command under the OSPF process is how it selects it, or it'll use the highest IP address of the loopback, and if that's not available, it'll choose the highest ID of the router's physical interfaces. But we're gonna do what? Manually configure it. So if there's a manually configured one, that's the one that's gonna go first. So I guess I forgot to mention that. So that's the another reason why I like to fact check myself too. I might be sitting here talking and spitting facts to y'all and realize, oh wait, you know what? It picks the manually configured one first, then the loopback, then the physical interface if it's up. Remember, it has to be up. So let's go back to this. We was checking the clocking. He says that there's a DCE cable configured there. I don't know if it's because this is the these routers don't tell you which side is doing the clocking or not, but I don't know. I haven't figured that part out yet. I need to figure that out. Maybe we'll do that after class, y'all. So back to interface serial 2/0. We say to configure the clocking, we do clock rate command. You question mark and to tell you which ones you can do. You can put only these values in, right? Or if you put a value that's somewhere around there, it'll round it up to the nearest value. Remember we did that last time? We had to Google it because you can only enter it in bits per second. Unless you got a damn brain like Encyclopedia Brown or Kelvin Tran over there, you're going to have to convert the number from bits to kilobits per second, right? So in my case, let's go ahead and bring this bad boy up and do, we're going to say 768 kilobits, and see I already got it in my save command right there, right? To set let's say kilobits per second to bits per second, so that means we gotta use that number right there, right? I converted 768 kilobits per second to how many bits per second, which is 768,000, right? And then after that, the computer is gonna basically round that number off to the nearest value for you, the one that it supports, right? So in this case, back to GNS3, all these goddamn windows. Right, put that in there, right? So remember, it said you can only use these values right here, right? 1200, 2400, 4800, 9600. But remember, this is bits per second, right? We're going to use 768. 768 falls somewhere in between 128 and 64, so it's gonna fall somewhere in between here, right? This is gonna pick the round. It's gonna round. It's gonna say if this will accept the clock rates. It'll be best fitted or rounded to the nearest value supportable by hardware. I like how they did this. In case you don't understand what best fitted means, they're like, that means rounded. In case you don't know, to the nearest value supported by the hardware. What's the nearest value? Press enter. It says right there, clock rate best fitted. In case you don't know what best fitted means, that means rounded to the nearest value, which is 733,090. You see that? Check our work, right? So controllers, serial 2/0. Y'all with me so far? Yeah, man, but he's a really smart kid, man. Really smart kid. I like him, man. He usually pops into our Discord server. In case you guys don't know, we have a Discord server. In case y'all have any other questions, or if you want to hear me talk some more shit, that's the Discord server if you guys want to join. So we do serial controllers 2/0, and we'll see the line status up. What do we change? There's the clock rate right there, 733,090. Just remember last time it said, what did it say right there? That was the received clock rate. I don't know why I say received if it's going to be doing the clocking. I thought it would be the other way around. I gotta read a little bit more about what clocking actually is. I ain't gonna front for y'all like I know what the hell it is, but I know it's usually one side that does the clocking and the other one receives it. So, and they said something about modem, so I need to really do more of a deep dive on what that is. So, and I'm not gonna make pretend I know. So, we did the host names, we did the clocking to provide the clocking to router 3. So we don't have to do anything about clocking on router 3, but we do, or not router 3, but router 4 in this case, because I couldn't figure out how to change the damn host names. Configure the IP addresses. So we got to do that again. This guy, so interface, serial 2/0. Not for nothing though, plant-based brother. I'm glad you was able to knock this out before we did in less than 6 minutes too, man. So congrats, props to you for that. But in case we run into any issues, you still showed up, man, and you said, I'm gonna either help him out or see what he did differently, man. So that's great what you're doing, plant-based brother. We got to do the interface, the IP address for this guy, which is IP address 172, right? This guy right here. And we said we didn't do the configuring yet. All right, so 172.16.1.2 subnet mask of /26, which is .192. We're gonna no shut that bad boy. Check our work with show IP interface serial 2/0. Oops, not 0/2, 2/0. And we had a busy at work today, man. Unfortunately, I was working remote, and we had some wireless issues, man. Luckily, my coworker is hella smarter than me, and he knew what the hell he was doing. Yeah, we had some wireless issues. I don't like wireless, man. I thought I tried to do some specialization. I tried to do some more wireless stuff on this channel, and then I realized I'm not a big fan of wireless, man. I bought some wireless controllers, bought some APs, and tried to really get into it because my last job they was really looking for some wireless people too. So that motivated me to get into that. But so it says here. Enable OSPF in area 0. So that's 3 now, right? Enable OSPF in area 0. Remember we said area 0 is the backbone area, right? We got Danielle Williams in the building. What's up, Danielle? Do you know what OSPF stands for, Danielle? OSPF in area 0 between router 1 and router 3. For router 1, use process ID 1. For router 3, use process ID 3. But remember, I got router 3 and router 4. So I'm going to use, I'm going to use different process IDs. I'm going to use process ID 3 and 4. That's what I'm going to do, right? Verify that your adjacency has formed. Make a mental note of the router ID being used at the time of the adjacency after the adjacency between router 1 and router 3 has been established. So we got to figure out what the network address is again. Magic number, I want to say, is 128. So it's every 64 networks. Yes. We start with 128. So it's every 64 networks. So the network address is still going to be .0, right? Y'all know what? You see what I did a little bit of subnetting here, right? So because of this subnet mask, it's not like /24 or /16 or any perfect class full address, right? Like /8 or even /32, right? It was a little off with this subnet mask. So I had to figure out what the subnet is, right? It's pretty simple, right? Well, it's not pretty simple. I ain't going to say that. The network address is every 64 networks, right? So in this case, the first network will be 172.16.1.0. The next network will be 172.16.1.64. Then after that, it'll be 128. But remember, since this number falls between 1 and 64, then his network is 1.0. Same thing with him, 1.0. Like I mentioned before, there's an app called Practice Subnetting in case you want to, only serious personal fans. Not quite. Jesus. Okay, so router 3. Let's go ahead and configure OSPF on that bad boy, right? We said we go to global config mode, right? And to configure OSPF, we start off with the keyword router, not just OSPF, right? Other private routing protocols, we started off that way too, right? So in case we want to do BGP, we would do router BGP, and then we would put the ASN number. If we want to do EIGRP, we do router EIGRP, and then the ASN number. In our case, we're doing OSPF. We're doing router, OSPF, and then the process ID. Remember, because OSPF works with areas, they don't work with ASNs, and then we work with process IDs, which is a locally significant number. And that's the reason why these past couple streams, they made the process ID different, just to show you that they don't got to match. EIGRP, it would be like router EIGRP and then say 10, right? The other one has to say 10 too, if that makes any sense for y'all, right? So in this case, OSPF, we're going to put him in process ID 3. You can do 1, you can do 5, you can do 999 if you really want to. We'll do 3, right? Since he's router 3. That puts you in router config mode for OSPF. And then we need to write our network statements, right? Remember, with the network statements, we're saying which interface, whoever falls into this network, whatever interface falls into this network, broadcast OSPF out of that interface, and also add him to that area. So in this case, we're doing network. Oops. And then 172.16.1.0, not 1.1, right? Remember, there's an app called Practice Subnetting if you need to, learn how to do some mental subnetting and stuff like that. Professor Messer has a video called, I want to say 7-minute subnetting or 7-second subnetting. I can't remember. But if you go to YouTube, you just type that in and he shows you like the shortcuts, like the magic number and stuff like that. Who else has a good video? Dewan Lightfoot. You check out his YouTube channel. He has a video series, I want to say. It's called Subnetting Like a Boss. And he shows you shortcuts and how to do some mental subnetting and stuff like that. That's a great way to do it too. We got to do the wildcard mask, which is /26, right? Remember, we said the subnet mask. Remember, it's the reverse of a subnet mask, right? So we said the subnet mask was 255. Where is he at? Same thing we did last time, right? .192. That was a subnet mask. Remember, we take 255 and then minus the subnet mask. That's going to give us the wildcard mask, right? So in this case, 255 minus 255 is 0. 255 minus 255 is 0. 255 minus 255 is 0. And 255 minus 192, I ain't going to pretend I know that. 255 minus 192 is 63. And that's how we come up with the subnet mask. Y'all with me? Right? And we said we're going to put them in area 0. 0. You question mark, and you'll see it says character returns. That means we ain't got nothing else to type. You press enter right there. Let's show our work so far. Show IP protocols. And we'll see we enabled OSPF process ID number 3. And look, we have our router ID already. It's 172.16.1.1. That's guy right here. So that's our router ID, right? But remember, the book called for lab number 49, in case you guys don't know. If you want to follow along, get you a copy of this book, like I wrote it, from 101labs.net. You can also get a copy of it there's a link in the description box below. It'll take you to Amazon, and it's an affiliate link, so I do get commission. It's authored by Paul Browning and co-authored by Farad Tafak. So get your copy of this book. This book called for, on page 212, lab number 49, to configure the router ID manually, right? So we configured it. This was done automatically, so he gave us a router ID manually, right? So when we start looking for OSPF neighbors, we'll be like, hey man, you speak OSPF? Yeah, I speak OSPF too. Okay, let's become neighbors. And we just start exchanging the databases, blah, 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 blah. My router ID is blah, 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 blah. So that was selected automatically. We're going to change that. And that's what it's going to call for, right? These are the networks we're routing for. And remember, our administrative distance is 110. Anybody have any questions or anything like that? I actually found you through Duan. That's what's up, man. That's what's up, man. yeah, I guess we kind of like in the same sort of community and stuff like that. You know, he has a little community called #lab every day. He used to wear a shirt and stuff like that. I don't got it right now. It's somewhere in there. But yeah, he got a great channel. So router, what else we needed to do? Some other show commands that we can run is show IP OSPF interface, right? And we say what interface is being participated, right? So you press enter. If you just do interface, it'll show you all the interfaces that are participating in OSPF. In our case, we only have one interface, and it's participating in OSPF. What interface is that? 020, right? Because he fell into that network, this network right here. He fell into that network. And then that's the wildcard mask, which is, remember, the opposite is kind of like the reverse of a subnet mask, right? So our process ID is 3. So it just breaks it down for you a little bit differently. This show command right here, show IP OSPF. You could break it down and put the actual interface and do show IP OSPF serial 2/0. But if you have more than one, it'll pull up all of them when you do it that way, right? The other way, right? We said this is a point-to-point network, not broadcast, right? Because it's point to point, right? The cost is 64. So this neighbor right here is that's how much it costs us to get there. That's not to be confused with administrative distance. Remember, we said hello every 10 seconds to our neighbor, right? And then we consider him dead 4 times the hello, so it's 10 times 4 is 40, right? So we say hello every 10 seconds. If we hadn't heard from him in 40 seconds, we consider him dead, right? Our neighbor. I forgot what wait and transmit stood for. Retransmit. I believe it's we'll check again in about 10 seconds. But we still say hello every 40 seconds. I'm gonna have to double check those two. OOB, I think that's out of band resync timeout. The hello is due in that many seconds, right? So if we check it again, I'll show y'all, right? Let's move on, because I don't want to do too much of a deep dive here. So let's go ahead and go to router 4 and put that interface to participate in router OSPF. Make them become neighbors, right? Because remember, if we do show IP OSPF, see if we got neighbors. Hey, we got any OSPF neighbors? Hello? No, he ain't got no neighbor yet. Why? Because he's not participating in OSPF. So we're gonna make him participate in OSPF. Y'all with me so far? Anybody any questions or anything like that? Go to global config mode. We say router OSPF. We'll put OSPF 4 network. The network address is 172.16.1.0, and then the reverse subnet mask is the wildcard mask, rather. I just call it that. That's just something that's something I call it for me to remember, right? To come up with a wildcard mask, I can do 255 minus whatever that number, the original subnet mask is. That's gonna give me the wildcard mask. That's how I remember it. So area 0, and theoretically he should. And see, he already came up as a neighbor. Remember last time we had some issues because we had a switch in between, and that switch has, you know, it has some sort of GNS3 bug where it just be messing with me. Y'all know GNS3 don't like me, man. GNS3 don't like me, man. So now we became adjacent with that neighbor right here. The process ID was 4. Remember, the process IDs ain't got a match. The number is 1.1. Who is that? On serial 20. So that is his router ID, right? So let's check the serial interface over here. Show IP OSPF interface. I ain't gonna do 2/0, right? My router ID is 1.2, right? Whereas his was 1.1, right? That's him on the left, right? We're both in area 0, right? We're router 4. I'm in area 0 as well. Here's my router ID, point to point. The cost is 64. What else we got to say? We got the same hello timers. That's another thing too. Those got to match. You can actually change how many times you say hello. If you change the hello timer to, let's say, I don't know, 15 seconds, the dead timer is automatically what? That's another pop quiz for y'all. Since if I change my hello timer to 15 seconds, so I'm saying hello to check for any neighbors or check on my neighbor every 15 seconds, what would my dead timer be? Right? The next hello is due in a second. If we run it again, you'll see. But let me stop messing with that. So task 3 was to make the mental note of the router ID, which was 1.1 and 1.2. That was selected automatically. Right? What else we wanted to say? Make a mental note of the router IDs at the time of this adjacency. Let's do one more show command before we change the router ID, right? So we're going to do show IP OSPF neighbor, and we'll see information about our neighbor, right? So my neighbor's ID is 1.1, right? This is from router 4's perspective, right? My neighbor ID is 1.1, that right there. The priority is whoever has the highest priority becomes the designated router. Remember, we talked about that, right? The designated router is the guy who is going to be keeping the list of routes, the OSPF routes. He's kind of like the main guy in OSPF, right? But notice we don't have a router and a designated router here. It would have said DR or BDR here, right here. Y'all know why it doesn't have that? Because this is a point-to-point network. It's only 2 of us in here. We ain't gotta have no backup or no designated. Because remember, there's a designated router and then a backup router. It's kind of like president versus vice president. If there's only 2 of us in here, why we need a backup? I mean, a main guy and a backup guy. If it's only 2 of us in here, so that's why they don't have that on point-to-point networks, right? Remember that concept. The dead time when we consider our neighbor dead. Remember. This is the neighbor's address. Now this is different from that address versus the neighbor ID. Pay attention to that right here, right? Task 4. And then after that, we'll wrap it up. Manually configure OSPF router ID 1.1.1.1 on router 1 and 3.3.3.3 on router 3. Well, you know what? I got router 3 and router 4, so I'm going to manually configure the router IDs to be 3.3.3.3 and 4.4.4.4. So if you're following along, y'all can do router 1 and router 2, but remember, for some reason, my router's racking funky. I don't know if it's because I dragged and dropped and deleted, and they just ended up being router 3 and router 4, and I didn't feel like changing all that up, just for the sake of this lecture. So reset, and then it says reset OSPF process on router 1 and router 3, issuing the clear IP OSPF process command. So that's the other thing too. We changed the router ID. We could change it manually, right? But it is not going to take effect until we clear the router ID process. And that's what they're going to have us do with this command, right? So let's go to router 3. And I believe to change the router ID, you got to go to the process first, if I remember correctly. Configure terminal, right? And we're going to say router OSPF. The process ID was 3. Remember, because you can have more than one process on the router. So I could have like router OSPF 10 and 3. But you need to go to this specific process in this case, right? So we're going to say, what is it? Is it just router ID? Yeah, that's how you change it. You just type in, you go to the process, and you do router ID. In my case, I'm going to change the router ID to 3.3.3.3, right? And then it says here, right here, reload or use the clear IP OSPF. It even tells you right there. Clear IS OSPF command for this to take effect, right? That's what it says. We got to reboot the router or run that soft command right there, which is clear IP OSPF process for the router ID to take effect. We'll even show you. You show IP OSPF interface, right? And we'll see the router ID is still 172.16.1.1, right? So let's go ahead and issue that command and see what happens, right? Clear IP OSPF process, and I think you got to put the process. No, you don't put no question mark. What am I doing? We do that. Reset all processes. You can. It's going to ask you, hey, you sure you want to do this? Because if this is a production network, and you got like 20 routers or whatever, you know, you could mess up the database if he's a designated router, right? So by default, it says no. We're going to say yes here. Press enter. Clear the process, and notice basically the router ID, the neighborship pretty much bounced. So it went from full to down, right? We no longer was neighbors for just that small little second there, and then it came back up. Went from loading to full. And remember the states here, right? Let me go back here. Do I still have it up? Yes. Here are the neighbor states. We start off in down, then we make an attempt, then we go to init or initial or initialize. And then we go into two-way mode, and we go to X start, then we go to exchange, then we go to loading, and then we go to full. Once we become full, we're neighbors. Remember, I'll leave y'all a link in this description. Leave y'all a link of that document. It's a Cisco white paper to learn about the loading states for OSPF, right? Is it init, initialize, right? So, and then once we're in full, that's when we become neighbors, right? So that's what happened there. The process bounced. So now let's go ahead and check our router ID, right? So how we check it? Show IP OSPF interface. We see now our router ID is 3.3.3, right? So if we go to router 4 and notice we got the message here, hey, it bounced. It went from full to down. Then it went from loading to full, right? And then we became neighbors again, right? Loading done. You see that? We got two messages there, right there. This is when it went down. Hold on. This was when it went down, and this is when it came up, right? So now we do a show IP OSPF again, neighbor, and now our neighbor ID is 3.3. Compare it to this show IP OSPF neighbor output to this one, right? Our neighbor ID is now 3.3.3. This is from router 4's perspective, right? Our neighbor is 3.3.3. The priority is still 0. The state is full. This is the dead timer. But the address is 1.1, 172.16.1.1. So the physical interface is still that, but the router ID has changed. So this is the router ID, and this is the physical interface that we learned at OSPF, basically like he's, the interface that he's speaking out of, our neighbor, which is 02.0. Y'all with me so far? Anybody got any questions or anything like that? What's up, Tori? Shout out to Tori Davenport. Where you tuned in from? Remember, week 2, we typically live stream Monday through Thursday, 8 p.m. Eastern Standard Time. So this is the last lecture for the week. We're gonna do another stream on Monday. So task 4 was to make a mental note of the router IDs. So then now that we've done that, let's do the same thing on router 4. We're gonna change his router ID, right? But before we do that, let's look at router 3 and see real quick, right? So that way we compare it, right? Show IP OSPF neighbor, right? So now, what am I doing here? OSF, it's PF, right? Only serious personal fans. Neighbor, right? So his neighbor ID, this is from router 3's vantage point, right? His neighbor is 172.16.1.2, right? And then the priority 0, the state is full, the dead timer. His ID, the physical address is 1.1, right? 02.0. So let's go ahead and change the router ID on this. Y'all remember how to do that? Global config. We say router OSPF. The process ID was 4 in this case, right? And then we said we changed the router ID with just the router ID command under the router ID process, or the router process rather. And then we said his ID is going to be 4.4.4.4. If you're using, GNS3 or packet tracer or anything like that, you can follow along this way. If your interfaces might be different, your interfaces might be different, you can change router ID if you guys want to. We press question mark, we'll see that there's nothing else to enter. We do that, and it says the same thing. You either got to reboot the router or click the clear IP OSPF process. If we're in a production network, we probably won't want to reboot the whole router. Right, we might take down our connectivity with our users and stuff like that. So this is what's known as like a soft reset when we do this clear IP OSPF process, right? There's actually like a BGP version of this as well. I forgot what that is. I think it's soft BGP something. I can't even remember. So we'll go with the clear IP OSPF process. Clear. Come on, man. Come on, lad. You got to get out of router ID config mode. Clear. You got to get out of global config mode. Clear. IP. OSPF. Look at me, man. You could do it by process, right? Let's say we have 5 processes on here. You could pick a specific one. Remember last time we just pressed process. We just did process. That resets all of the processes. Let's try to do just one process, right? Which in this case was process ID number 4, right? No, you can't do that. Process ID 4, and then after that, there you go. You got to actually type in process. You see what I did there, y'all? That we're not doing the whole thing, putting me on the spot like that. But do you know what TFCBT is? I'll give you a hint. It's a type of therapy. Let's see. If y'all don't know, she does mental health, and she likes to quiz. I like to quiz her on CCNA topics, and she likes to quiz me on licensed mental health clinical topics. TFCBT is BGP soft neighbors, in and out, no loss of neighborship. Oh, that's what's up, Tori. Appreciate that. See, I knew there was a soft command as well. I'm gonna guess therapeutic fundamental computer-based training. Am I correct in saying that? I don't know. I just took a wild guess. So, what was I going to say? So the process, we're going to clear the process right here, right? Press enter. Do we want to reset that process? So last time I asked us, do we want to set all processes? We're asking for a specific process right here, right? So we say yes. And that should bounce the neighborship, right? Full to down, loading to full. You remember the neighbor states? I put it in the chat box in case y'all don't know what they are. And now let's run show IP Ospf again. Neighbor. Remember last time we did it, it said that our neighbor was, no, we need to do it from this guy's perspective, right? So it bounced there. We said our neighbor ID, right? So from router 3, his neighbor ID was 172.16.1.2, full, and then that was the address, right? We run that command again, and now his neighbor ID is 4.4, but the physical interface is still that, right? Because we didn't change the address of that interface. We just changed his router ID. Right, so now when he's looking for OSPF neighbors and stuff like that, he says, hey, man, you speak OSPF? Yeah, I speak OSPF too. Well, guess what? My router ID is 4.4.4. You have any OSPF routes? Yeah, sure I do. Here you go. Let's. Are you missing this route? Yeah, I'm missing this route. Do you know how to get here? Yeah, you know how to get... And then we become neighbors. It comes full, right? That's pretty much the process of router OSPF neighborship. What are we missing here? That was task 4. Verify that the OSPF adjacency has been reestablished between router 1 and router 3. In my case, router 3 and router 4. Verify that the OSPF neighbor IP addresses are now showing as the manually configured router IDs instead of the physical interface IP addresses. And that's what we did with the show IP OSPF neighbor command, right? Let's see if there's any notes here that they have in the book, and then we'll call it a night. Show IP OSPF neighbor detail. Oh, I didn't know that one. Let's do that. So we do the same thing and type in detail. I didn't know this. What am I thinking? I just forgot to put the detail, right? So we do details, go give us more information, right? The neighbor is 4.4, and then the interface address. So it tells us in specifically what each is. It's in the area 0. Remember, this is from router 3's perspective via interface 02/0. Nope, I was wrong. Trauma focused cognitive. Man, listen, man. I'm not even gonna talk about that, man. So neighbor priority is 0. State is full. We got 6 state changes. You know what they are? The 6 state changes are when we was bouncing it, right? 1, 2, 3, 4, plus the first 2 when they initially became neighbors. So that's why there's 6 neighbor state changes. The designated router, we don't have a designated router and a backup designated router because remember this is a point-to-point network. I'm not even gonna break all this other stuff down. That's too much of a deep dive. Maybe when we start doing this, we'll start getting to the CCNA level or CCNP level. We'll start breaking down these bits and stuff like that. And we'll do more Wireshark captures. The neighbor has been up for 1 second. 1 second? 1 minute. Right? So we run it again. We'll see that the neighbor has been up for 2 minutes. Right? We don't got to worry about all this other stuff. That's too much of a deep dive there. What else they wanted to say here? The IP OSPF neighbor detail command provides detailed information on the neighbors. It provides the router ID as well as the interface on which the neighbor was discovered. So does the one without detail does. Among other things. In addition, it will provide the IP address of the routers that are DR and BDR respectively on broadcast or NBMA network types. Remember, this is not a broadcast or NBMA. This is a point-to-point network. So that's why we don't have border designated router or backup designated router and a designated router. Familiarize yourself with the information. Whenever you manually configure OSPF ID, router ID for an established relationship, the change is not immediate. And you have to either reboot the router or reset the process like we did, as indicated in the message that's printed in the console. That's what I like about OSPF, because sometimes it'll tell you, look, man, this is what you got to do if you want to do this. And then it says, are you sure you want to do this? And then it allows you to do it. And that's pretty much it, man. Next time you guys want to follow along, get you a copy of this book. There's a link in the description box below. You get a copy of it from also 101labs.net. It's authored by Paul Browning, who was in IT field for about 10 years, or I don't remember how long, but I'm sorry. He was in law enforcement for a while. Then he started his own IT training company. And it's authored by Faraj Jafar, who is a CCIE, and they both authored this book. I love this book because it allows us to practice the theory hands-on. Next lab is to configure OSPF passive interface manually. Lab number 50. So we'll start with that on Monday. So we're still doing OSPF. Y'all remember, I want to say maybe the next I'm not gonna do it on this book. Maybe we'll get to we'll get to the IP services, and then I'll do the labeling and cabling offline, so that way we can get to what we need to get to, and knock out the lab as quick as Plant-Based Brother did. Later, Josh. Appreciate you for tuning in there. And that's pretty much all we got for today. We have a Discord server if you guys want to join. Let me go ahead and put that in there. In case y'all want a little bit more commentary from me, y'all know I'll be talking about some, random stuff on there. Go ahead and join the Discord server if you're not joined, or if you want to see a little bit more of this stuff. Go ahead and join my man Josh from Keep It Techie. He has a YouTube channel as well, and he does stuff, man. Appreciate that, Tori. Thank you for tuning in. Check out my man Josh from Keep It Techie. His YouTube channel focuses on Linux stuff, and as a network engineer, we need to step our Linux. At least I do need to step our Linux game up, because a lot of even iOS, this operating system, is based on Linux and stuff. So, not Dynamics, I don't think. But either way, iOS is based on Linux. The command structure is pretty much not the same, but it's very similar. So if you want a little bit more of that, y'all go ahead and subscribe to his channel. And that's pretty much all I got for y'all today, man. Leave me a comment if you like this video. Hit me with a like button, man. What is the link for that CCNA site? It is, let me give you that link. Yeah, free website, man. There's tons of free CCNA websites, man. I've got a whole bunch of them, man. If y'all want, I'll put them all in this chat here, man. I just, love this stuff. When I see some that are free, I collect them and save them, put them in my favorites, man. Cisco study material. What is it? Study CCNA for free. It's study-ccna.com. Let me get you that. But they also have other stuff too, so give me a second there. That is the link for the CCNA site. Study-ccna.com. Free website. They give you all the topics, man. Even configuring router OSPF. Manual ID. The router ID. So, yeah, check that out. You'll see. If you even go to OSPF, in the OSPF overview, it'll show you about what we did today. So, and that's a free website. So, check that out. Share these videos, man. Share these on your Discord server, any other Discord servers you're in. If you like my teaching style, my teaching format, share them on Instagram as well. Y'all know I keep it funky on this channel. For now, comment, like, subscribe.